Chapter 12. Okay, first thing we're going to do is go over the stats, medics, SAT answers that were due today. Then we're going to go over the Chapter 12 notes, and then we're going to do our assignment for today. Okay, so what you should have done is in the SAT prep improve scores. In this situation, it's an observational study, and what I'd like you to be doing is taking a pen and go ahead and writing the extra notes that I have on here, and you're going to be uploading these notes as credit that you have just completed the assignment. So the reason it's an observational study is I'm observing. Imagine someone coming, a principal coming into my room and observing me teaching, and they're merely doing that. They're not interacting, they're just observing. The big thing for observing, no treatment. You're going to hear me again, no treatment, no treatment, no treatment. If I say, how do you know it's an experiment? Treatment. How do you know it's an observational study? No treatment. So this one is an observational study because the students are not forced to take the class. They can choose to. So explanatory and response. Remember, explanatory, explanatory, and response is the outcome, which is my Y. And remember, I'm using the explanatory to predict, and I'm predicting the response. So the explanatory is the SAT prep class, but notice I marked out SAT prep class. It's whether or not, because those are the levels. You can't just say SAT prep course because what about it? So you need to make sure you put that, otherwise you would not receive credit on the AP test. You have to put the level of the SAT prep course. Level meaning they took it or they did not take it. Response is the SAT score. You cannot conclude that it will cause. Be very careful. I guarantee you will see this in the multiple choice particularly. In one of the multiple choice options, it'll say something cause. And if you see cause, you circle it. And most of the time, it's not the right answer. Be careful. It can never be cause if it's an observational study, because the students who take the prep course might be highly motivated to study more anyway. But what we're saying is we have not controlled the variables to be able to say that this is the cause. We're not saying it's not the cause. We're saying we do not have evidence to show it's the cause. You have to have an experiment right here to show causation. That is very important. Identify other possible variables. These are the confounding variables. You could have come up with other ones, but these are some that I came up with: motivational level, college bound, time after school. This here, if you notice, whether or not someone took the SAT course, did that cause the SAT score, or did the motivational cause SAT score? Notice there's a correlation between the two of whether or not they took the course and their score, but was that the reason, or was there something else that was one of these out the side reasons that were not controlled? So design an experiment. I'm going to show you two ways to design the experiment. You could go ahead and write it out the way I wrote it out in blue, or you could do a design, and either one would be 100% correct and full credit as long as you wrote everything in it here. The biggest thing here I'm going to show you the design is this here. Is you have, okay, I chose 100 juniors. Now that does not have to be random for my experiment. What needs to be random for my experiment is the treatment. So I'm going to randomly assign them to group 1 and group 2. Roughly equivalent, doesn't have to be exact, but I'm going to try to get them as even as possible. Then group 1 is going to take the SAT prep class, and group 2 is not. And those are the treatments. Then I'm going to compare the SAT scores. If you read through the blue, it basically says the same thing. Either one would be correct. So this is what you're going to have to write down. You might want to put this on pause. But learning target 1, the A, B, and C, that's just saying, was back here what I was showing you, was that did the response variable cause did the explanatory cause the response, or did some confounding variable? So, and that's what this shows you here. For learning target 2, observational study, as I went over already, that's key thing is no treatment. Experiment is as a treatment, and that I'm allowed to show causation. I can say this caused this, only an experiment. Experimental unit is what or who the treatment is imposed on, and treatments, what is done or not done to experimental units. All right, let's look for checking for understanding. Does reducing screen brightness include battery life? And this is, what is this? And is it an experiment? Because its treatments were imposed. And I'm going to state the treatment. The treatment was adjusting screen or not. Make sure you put that level. For the second one, yes, it was an observational study because there was not assigned treatment. No assigned students to eat with their families. They did not assign them. It was completely optional. For number 3, explanatory, whether or not, notice that level again, whether or not the teen ate with the family at least 5 times a week, response was grades. Number 4, we cannot say it's cause and effect because teens who eat with the family may have something in common that affects their grades, like a healthy diet. Experiments are only the things you can have as a causal relationship. Observational studies cannot. All right, if you're flipping your packet to the notes, I'm just going to go quickly over the notes for you so you have these notes, and you can read through them yourself, but I will just kind of go through them with you as quickly as possible, and you can go through them and just fill them in. If we want to observe individuals to record data in any intervention, we are doing an observational study. Now, there's 2 types. There's retrospective. I think of retro, when you dress retro, you're looking back, or prospective when you're looking forward. So a retrospective study would be like, I am studying you and I ask you what you did when you were, let's say I was asking your style. What color did you like when you were 5 years old, 10 years old, 15 years old? That would be retrospective, the past. Prospective is when I continue to study you when you're 20, 25, 30, and so forth. Notice this says causal, not casual. That's causal. So you can't have a causal relationship. You only can have a causal relationship with an experiment. All right, experimental, this just tells you that individuals, what they're called, are subjects. If they're not a person, it's an experimental unit. The treatment is the experimental addition week 2, and it's anything that we do to manipulate the variables. It does not have to be like me feeding you or this, that, and the other, but this honestly could be treatment. What I'm doing right now, treatment is, what effect are you going to do? How much are you going to start going crazy or be like, what are you doing, Ms. Brown? It's because I am trying to see how many times you will try to maybe fix your computer or figure out that it's something going wrong with the computer or whatever, how long it'll be after you see me moving this up and down. All right, that would be a treatment though. Observational study is I do not influence anything, and I just look what's going on. There are factors, and there are also, the factors have different levels. Remember, whether or not is the level, and the factor would have been what we were talking about before, where eating with the teens eating with the family, and then would be the factor, and the level would be whether or not. We're trying to minimize lurking variables by a control group. A control group is someone that I do not do the experiment to, or a placebo, or the current treatment. For instance, if I'm taking Advil and I want to see if there's a better medicine than Advil, I could have the current group. I could have a whole bunch of people that currently take Advil in one group, and then the new treatment, maybe Excedrin or Tylenol or something, in the experimental group. So a control group can be the current treatment of what they currently are using. It doesn't have to be no treatment. It doesn't have to be a fake treatment, but those are the conditions. Okay, choosing a treatments. Identify factor and levels, control group, and assign matching experimental units. You can match them, which we're going to talk about in a second, and you need to make sure you have randomization. So remember, cause and effect is only experiments. Okay, this is the principles of experimental design. CRR is control, randomization, replication. Those 3 things you have to have in order to have a good experiment. If you can block, which I'm going to talk about in a second, that's ideal. But these 3 are absolutely imperative to have a good experiment. So an effective called statistically significant. If I'm saying, hey, wow, that happened just too often to be considered by chance. Even a well-designed can have hidden bias. So we try to do a blind experiment. And the blind experiment is when when the subject does not know what is actually being measured in the experiment. And a double blind is neither subject or the person in contact with them knows which one's the treatment. So for instance, if I was giving you Coca-Cola versus Pepsi and I asked you which one you liked, well, if it was going to be blind, I would be giving you two cups that look identical, and I would be giving you the drink, and I would give you one and the other, and then you would tell me which one you liked. That'd be blind to you. If it was double blind, I would have a third party putting the drinks in the cups for me, labeling them A and B. They would know, but they would not tell me, and then I would take them to you. I highly recommend that's how you do anytime you do your experiment, when you conduct your experiments. Okay, types of, there's completely randomized design, and that's where all subjects are completely randomized to their treatment. All right, and let me just show you. It kind of looks like this, where we and I can write the word random, but this was kind of like the SAT one, where it went like the juniors that we had for here, and it went to group 1 and group 2. So that would be like a randomized design completely. A block design is where, let's say I have juniors, and let's say I put males here and females here. And then I randomly put them in group 1, group 2, random. Sorry, this is messy. Group 3 and group 4. Well, here, group 1 and group 2 would both receive, just like we did this experiment, basically this here would look the same as this and this. Meaning, let's go back really quickly and look at our junior experiment. So this here, instead of it just being juniors, what I would do is I would, first of all, before I'd block them, before I randomly assign them, I would do block, and I would assign males here and females here. And basically, I would take this identical experiment that I did for males and do it for females. And the reason I would do that is, let's say that I found that males are responding differently to SAT prep than females, and so I wanted to compare males to males and females to females. You often would find that with anything to do with genetics, or something to do with things that we would see that traditionally females would respond differently than traditionally males did. And so we would want to, or if we notice different races were responding, or different ages were responding differently, we would want to group them and measure them against people that were similar in nature to them. Okay, a matched pair design, that was where there are only 2 treatments. And so a matched pair is where you match someone that is really similar to you. So for instance, if I had a new shampoo that I was testing, and I would maybe want to do texture of hair, and I would want to put 2 people that had a similar texture of hair in the group. So I would put match pair 1 here and pair 2 here. And then I would randomly assign who gets the treatment and who gets the placebo. So let's say pair 1, again, that's going to be a random, because I can't just say, oh, I'm going to give you this, because remember, there's hidden bias, and we want to make sure we don't have bias. So I'm going to maybe flip a coin or something to see who gets the treatment, and then the other person gets the placebo, and then I can compare them. Now, the best match pair is me, because I am most like me, right? Sometimes you can't. Like if I'm doing shampoo, I can't shampoo the left hair and the right hair, so I have to do something different. And the way I would do that different then is that I would have the match pair with people that are as similar as possible. But the reason I would say me is this. Let's say I want to know, do I perform math problems better with music or without? Then maybe I would give my subject 10 problems of math with music, and then 10 similar problems without music, or vice versa, depending on which randomization they got to do first. So that would be a matched pair where I am matched with myself. Okay, a lurking variable, again, is caused by treatments of an association between 2 other variables that tempts you to say one causes the other. So confounding variables are in experiments and lurking variables you're going to typically see like in observational studies and surveys where confounding variables are in experiments, and when it's another variable is associated with a factor that has an effect on the response variable. Unlike the lurking variable, confounding variable is associated with a non-causal way, it doesn't cause it, and that affects the response. If you would go, you have in your packet a page just on lurking variables, and I would like you to make sure you highlight that and you kind of take a couple notes on it. It won't take you very long, but it specifically deals with lurking and confounding. Okay, for today, we are going to go ahead and flip to Would You Fall for That? And let me go ahead and play your video.
Hi, I'm Nick Watt from ABC News, and I'm here with my friends Sashir and Scott. And tonight, we're going to venture out into the real world to unlock the secrets of human behavior.
So, psychological experiments.
On people who happen to pass us by.
Exactly. Hi, my name's Nick, and I work for the WYFFT Power Energy Drink Corporation. Would you like to look like this?
I'm strong.
My trunks are tight.
Well, what's inside this bottle can make you feel strong. Twice the energy, 0 calories. It's our new WYFFT Power Energy Drink. Our shtick, we set up a booth on the boardwalk at the beautiful Jersey Shore one sweltering hot day. We told vacationers we're shooting an infomercial for a fabulous new energy drink. We had t-shirts and posters. We even had our very own WYFFT Power Energy Drink banner plate. Oh, and one tiny little secret. WYFFT is nothing more than club soda. You see, we're demonstrating the power of the placebo effect today. So all we did was tear the labels off of club soda bottles and stick on our own. WYFFT. Would you fall for that? Would you actually feel stronger after a few gulps? You will be amazed.
What we got going on right here is the WYFFT Energy Challenge. We're promoting a new drink, and it shows immediate results. Who wants to step up and take it? It's totally free.
Who's strong?
First up, we invite our passers-by to test their strength as a classic carnival high striker. Swing the mallet, try to ring the bell. 7. Now, Keith, that's respectable. It's not stellar. Sashir is going to give you some WYFFT right now, and we will increase your performance. WYFFT. So Keith chugs the WYFFT, and I tell him some highly convincing nonsense about what's in it. It was discovered by Philip Monroe, who won the Tour de France in 1998. Then we get him to shake his thing, get the WYFFT pumping through those veins.
Punch all those distractions out of your life. Don't punch me. All right, punch everything else, though.
And it's back to the high striker to see just how much stronger WYFFT has made him. Will he get a better score? Stand back, boys. Keith is on fire. Yeah! 10. Ding dong. Just like that, Keith has become a strong man.
Felt pretty good.
It did?
Yeah, a little burst energy.
Muscles, mind, where were you feeling this?
A bit of both.
Yeah.
Put in the mind.
Yeah. If you're wondering if we rigged that high striker, the answer is absolutely not. It's the placebo effect at work, and Keith fell for it. If you believe a pill will make you better, then it just might. If you believe an energy drink will make you stronger, it just might. Even if that energy drink has absolutely nothing in it to make you stronger, even if it's just club soda. It's a great trick our minds play on us. But to get the trick to really, really work, we had to make people really believe in our product. We had to hype this up. Yeah! This is pure. This is drained through a glacier in Switzerland. It is pure electrolytes from the Carpathian Mountains in Eastern Europe. It is filtered through a Slovenian volcano. The more mysterious the ingredients, the better. Extract of Serbian pear goes straight to your muscles, works within 60 seconds, lasts for 1 hour. The only thing that's in it is extract of African gooseberry. It's a fruit from South Africa, and it's then filtered through dolomite crystals. Then I ladle on some fake but sciencey sounding statistics. 28% increase in lab tests in power. then Sashir really gets them shaking it to really make them feel more powerful.
We're climbing to greatness. Let's raise the roof, push it higher. Ooh, I got whipped. I'm whipped up. Bring the world into you. Oh, yes.
You want it out there in all your muscles, so we need to pump it around the body.
She's buying it, but will WYFFT make her stronger?
We're trying to beat it 4. Yeah! 5.5! There you go, there you go. Talk me through the difference that you felt between pre-WYFFT and après-WYFFT.
Pre-whiff, I felt like I just was like slugging it. Then after the whiff, I felt like
I like to call it après-WYFFT, by the way. Just
après-whiff?
Après-WYFFT,
Okay.
yeah.
I felt like I had more umph.
You're gonna hit this, we're gonna see how high you get, you're gonna drink a bottle of WYFFT, you're gonna come back and you're gonna beat your score. Wow! She got an 8, she got an 8. Well done, well done. All right, so Sheer is gonna give you some WYFFT, go, and we're gonna watch you beat that score.
Oh, the power of club soda. I mean, WYFFT. I mean, the placebo effect. Now, Cynthia had to beat an 8.
Yeah! That's a 9! That's a 9! After you had it, how did you feel different?
I felt like an extra boost in my body.
Uh-oh, double the trouble. Could WYFFT work on a pair? In came Molly and Ian. And right off the bat, she's questioning his masculinity.
Can he ring the bell? All right, prove her wrong. Because clearly Molly does not think you can ring the bell.
I had to come up with ingredients so extraordinary that Ian couldn't help but fall under the spell. The placebo effect.
All that is in it is pondweed that grows on the eastern end of Lake Geneva. That is it. There's no caffeine. Pondweed. That is it.
I can taste it.
Really?
Did he just say he could taste it?
I can taste it.
WYFFT Power Energy Drink, now flavored with pondweed.
All right, we've got a 9 to beat. We've got a bell ringer on our hands. Yeah. Come on. Yeah.
And it works on Molly too.
Yeah. 5. They got a 5. What did the WYFFT do to you?
Bubbles really got me all pumped up and jittery.
It even works on kids.
You scored 3.5, and then you went up to 6 after a few sips of WYFFT. Where do you feel it? In your arms, in your core, in your head? Where is it?
Head.
You feel it in your head?
Yeah.
He's absolutely right. It is all in your head. But would Jeff realize it's all in his head?
Yeah! Jeff! You're the man! You're the man! I told you were good for this. Where do you feel it? Where do you feel the WYFFT? Where is it in you?
Everywhere. It's in my chest. It's everywhere.
Nearly every single person who took the WYFFT challenge beat their original score. The placebo effect is that good.
Felt pretty good.
It did?
Yeah. Burst energy.
I felt like I had more umph. I feel like
Okay.
my body just like more energy.
I felt like an extra boost in my body.
Bubbles really got me all pumped
Yeah.
up and jittery.
Remember, you're just drinking club soda. So how did our pumped up winners take the truth?
I think I've got a secret to share with you, that what you just drank there is club soda.
No, it wasn't. No, it wasn't.
Really? Club soda. Club soda. Because you know what? Your power is in there. You're strong. It's all in the mind. It's called the placebo effect. You think it's working on you, so it does work. It's in there. It's all in your head. I tricked you, you fell for it, but you know, in a good way.
Is it still 0 calories?
Yeah.
Okay.
Don't worry. That's all you care about?
We just got whipped.
You got whiffed.
With energy drink.
Would you fall for that?
So, would you have fallen for that? Or do you think you're too clever? We're on Twitter right now with the hashtag WYFFT.
WYFFT, what does that stand for?
Would you fall for that? Our show?
We have a show?
WYFFT.
All right, so go ahead and take the first couple minutes and fill this out. That means pause the video. Pause it, pause it. Okay, now Now that you have finished pausing it, let's go over the answers. So obviously they thought they were going to get stronger, and that's called the placebo effect. So here's some problems with this plan that they gave you. First of all, there's nothing to compare it to. There is no control group. Secondly, there was no control for other variables. Possibly it was sugar increase. Sugar increases pulse rate, not caffeine. Also, people know that they're drinking caffeine or think that they're drinking caffeine, so it could be in their heads. That's also placebo effect, so we should have had blinding for them. So they don't know necessarily what they're drinking, or have drink one thing and then try it, or drink another and then try it, or pair them into one group that does what we call quote unquote caffeine and the other one that's not, and see if there's a difference. And so there are solutions by what I just spoke to. So here's an experiment that you could do. You could completely randomize, this is a completely randomized design, just what I spoke about, where you have the 32 students, and then you, or how many ever students you have in your class or something, you randomly assign them group 1, group 2, and they're about equal. Treatment 1 gets caffeine, treatment 2 gets caffeine free, and that's the control group, and then you compare the change in heart rate for these particular students. You could write it out, or you could do it the way I showed you here. All right, so this is basically what you needed to get from this lesson, is that control groups are used to provide a baseline data for comparison. Blinding is when subjects are single blind, when the subject doesn't know the treatment. And then experiment is double blind, which we talked about already, that whoever interacts with them doesn't know what the treatment is given, so you have a third party assign the treatments and then give them to the evaluator, and then they can give them to the subject, so they do not know which ones they're giving. Placebo effect is when a fake treatment works. So I often talk about Rogaine. It's a hair regrowth system, and they found that probably about 60% of people did get new hair when they used Rogaine, but also in the placebo group, they also found that about 40% of the people actually regrew hair. So whether it was the process of massaging their scalp or putting things on or whatever, but the placebo group definitely shows that there are aspects that of just what you think you can do, you will actually do. Learning target 2 is conducting a random assignment. And to do that, you need to do a random assignment, you need to make sure you conduct it and you show how you're going to randomize. So you would need to label, meaning you'd need to number the people or number the objects, and then randomize it by rolling dice, flip a coin, use a random number generator, and then assign the treatments. But you have to make sure that you go through and show me what the random process is. You can't just say randomize it. You have to tell me how. The 4 key principles of experimental design, we talked about CRR, which is but you're comparing, which is control group. You're going to be comparing 2 or more treatments to each other. Your randomization, control all other variables besides the treatment, and then replication. Can you do this again? And so that you can establish differences. All right, go ahead and take a couple seconds and go ahead and do the check for understanding. Put the video on pause and then come back. All right, if you're finished, to explain why it's important to have a control group, it's because you always allow us to show how much electricity customers normally use. It provides the baseline of data, so you have something to compare to. Describe how to randomly assign treatments to 60 households. This is one way, and you're going to actually talk about how you're going to randomize. So you're going to label all households from 1 to 60. Use a random number generator to choose 20 different distinguished numbers between 1 and 60. Assign them to display. Repeat 20 more times to get the numbers, ignoring repeats. Assign them to a chart, and the remaining ones don't get anything. So you could have used a hat and put numbers in and shake it up, or a random number digit table, however you want. Letter C. What purpose of randomly assigning treatments is this? And it creates a roughly equivalent groups and balancing other variables. So the last thing is to create an outline of completely randomized design. And here you go, you random assignment. You can write the word randomization kind of like I did right here if you'd like. You don't have to write it here. You can just put it right in here, or you can put it in front of it, whichever you'd prefer. But you've got 60 houses and you've got a random assignment, and 20 are going to each group. And then treatment 1, you're going to display. Treatment 2 is going to be the chart, and treatment 3 is the control group. And you're going to compare the electricity usage. All right, so that's it for our lesson. The thing is, I would like you to do is for your homework, if you could go to, oh, it's the wrong one, to your FRQ. There it is. So I've got 2 FRQs I want you to do, but I don't want to overload you with homework. So if you do one of them, which is page 30, the 2004B, and then I'll have you do the next one the next day. If you have extra time to go ahead and do both of them, then that's fine too. But this is the one I want you to work on, 2004B number 2. All right, sounds great, and I will see you guys later.